Today we're fixing your time step and uncapping your frames. Introducing Iota. Before we begin, I do want to start off with a short disclaimer. If you're new to GameMaker or consider yourself a beginner, I recommend to bookmark this video, but then click away. Because besides needing to be at least an intermediate GameMaker user to follow the things we'll cover in this video, trust me when I say that your time will be much better spent learning different things as opposed to anything remotely to do with Delta time. And, depending on your needs, you might never even need to. With that out of the way, let's dive into the meat and potatoes. As you know, logic execution in GameMaker is tied to what it calls game frames. Every game frame, all of your step events execute their code once, all of your draw events execute their code once, all of your alarms tick down by one, timelines tick up by one, etc. And by default, a new GameMaker project has a target of 60 of these game frames per second, which means there's a budget of roughly 16.7 milliseconds that can be spent on processing the next frame to show the player. If the player's machine needs more time to process a frame, the player will experience slowdowns. Let's look at some scenarios. If your game runs on a very powerful machine, it might only need 3 milliseconds to process the next frame. So what does it do with all the time it has left? Well, nothing. It'll just sleep until it's time to put in work for the next frame. This means that a slower machine that takes longer to process a frame will sleep for less. This way, faster machines will never see the next frame earlier than anyone else. The frame rate is essentially locked at a maximum of 60 frames per second. Now, it's at this point that I want to stress that leaving the default target of 60 alone and doing nothing further is perfectly reasonable, and for a lot of games, more than enough. If, however, you really want or need to be able to run your game at any frame rate, you might want to look into what Iota has to offer. Iota is an MIT-licensed library for GameMaker written by Juju Adams that allows for running your game logic at your own frequency, completely independent from GameMaker's game frame target. It's easy to set up in a new project and comes with a few bonus features as well. I've created a small test project that I'll be using to show you how to set it up. There's 3 objects, 1 manager object and 2 player objects. Currently, the manager spawns instances of both player objects into the room, and the player objects look identical, both running the following code in their respective step events, allowing me to move them left and right. Now, instead of GameMaker executing our code every game frame, we want Iota to handle when our code should be executed. To achieve this, we need to set up a new Iota clock. IotaClocks tick independently from GameMaker's game frames, and we can set their tick frequency per second to anything we want. Let's create one in our manager object. Creating a new Iota clock is done using the new keyword. And setting the tick frequency per second is done using the setUpdateFrequency method. By setting it to 60, I'm now asking Iota to tick 60 times every second, which is how often I want my code to be executed. Lastly, to ensure that the Iota clock keeps running, we'll need to call its update method every step. And that is it for setting up the clock. Now, let's make it so that our player 1 object actually adheres to our clock. First, I'm taking the movement code out of the step event. We know that the step event is executed according to GameMaker's game frames, and we're looking to get away from that. Instead, what we need to do is add all of the code that we usually execute in the step event to our own method. Then, we need to register this method to the clock that we've created. To do so, we simply use the method addTickMethod on our Iota clock. And we're done. Player 1 is now registered to our Iota clock, whereas player 2 still runs in accordance to GameMaker's game frames per second setting. Now, both of these are set to 60, and so when we run the game, both players seem to behave the same. But watch what happens if I set GameMaker's game frames per second setting to 120. Big difference. Our player 1 still moves at the same speed, because it's still updating 60 times per second, whereas player 2 seems to be moving much faster because it is executing its logic 120 times per second. Okay, great. Now it doesn't matter how many frames the player's machine renders, our game will keep running at the same speed we expect. But now you might be wondering, how can we make use of all these extra frames? Since the position of the player is only updated 60 times per second, if the game renders 120 frames, that means that half of those frames is just the player sitting still in the same spot. Once again, Iota's got you covered. To achieve smoother looking results on higher FPS targets, we can make use of interpolation. Let's go back to our player object and define which variables we'd like to interpolate. In this case, we're looking to interpolate the player's X position. So, let's register X as a variable that we'd like to have our Iota clock interpolate for us. To do so, we simply use the variable interpolate method, specifying the name of the variable that we want to interpolate and the name we want the interpolated version of that variable to have, both as strings. Now, since the interpolated version of our X variable is called IotaX, we want to use that for the position to draw our player in instead. Let's give it a test. Beautiful, silky smooth looking movement. Now let's go over an issue that you'll most likely run into, and it has to do with player input. Currently, we've been using the keyboard check function to check if the player is holding down a key. And this works because the function returns true every single frame it's being held down. But let's take a look at a function like keyboard check pressed, as this one works differently. This only triggers a single frame, only the very first moment the key is pressed. And if our game runs at 120 frames per second, but our clock only ticks 60 times a second, it's possible that the single frame where this function returns true is not the frame where our clock processes a tick, and so our clock can only read out false, resulting in a dropped input. Don't worry though, Iota can also solve this issue for us, but we'll have to make use of its built-in input system. It calls inputs like these momentary inputs, and we'll need to define them for our Iota clock, and we can do this using the method defineInputMomentary. We give our input a name. I'm doing jump as an example, and then we specify the default value of the input. You can think of this as the starting value of the input, so our jump input starts out at false. Next, we need to set the value of our momentary input every single frame, somewhere outside of our Iota clock tick. I recommend the step event of whatever runs the update method on your Iota clock. To set the value, you use the setInput method, specifying the name of the momentary input as well as what the current value should be. Having registered our momentary input, as well as setting its value like this every frame, we've ensured that our game won't be dropping this input. Reading the correct value of this input is done using the function IotaGetInput, and so to check for it in our player, we can use it like so. Alright, we've covered the basics of using Iota in your projects. There are, however, two more things I really need to mention before ending the video. One is you can no longer rely on anything that GameMaker updates based on the game frames per second setting. So this includes the built-in speed variables, the alarms, and so on. And second, make sure to read the documentation. Functionality might change over time, and there's extra features that can make your life easier that we haven't covered, like time dilation and Iota alarms. I want to thank Juju Adams for providing the community with this awesome library. I want to thank you for watching. I'd appreciate a share if you found it helpful, and I wish you good luck on all your next projects.